So what is a good idea before you start doing SEM analysis is to mark areas of interest with a permanent marker on the rock side of your thin section. Okay, so this is what the SEM looks like at the Geology department. It is a JOL JSM 6610 on the left hand side. That protruding part is your EDS detector. The blue section is your basically where your beam forms. On the right hand side is your WDS detector, and the block in the middle is your chamber. So this camera takes an image from the inside of your chamber where your sample is. Okay, over here you can see the sample holder, and this is basically where your beam comes out. Okay, there's a backscatter detector that sits at the bottom of this cone, so it is very important that you do not collide. Okay, that being said, the only thing that you need to worry about is don't touch these settings. So you do not change the Z over here, and you do not rotate or tilt the stage. Okay, so R, T, Z you do not change. So this is the setup, and this is what you will be looking at. The left hand computer runs the machine, the right hand computer does analysis. Okay, so what can be seen here is that there can be 5 thin sections in here at a time, and 2 epoxies. So if you have epoxies, we'll put in 2 at a time and 5 thin sections at a time. Okay, so taking a look at the screen that runs the microscope. This is basically your image. This image over here is a picture of the stage. So we're looking at a rock sample in this position. This one says that it's ready. This says that it's backscatter electron imagery that we're taking at the moment. Yes, so you'll see that it's slightly blurry. That's because this is a fast scan. If we change it to a slower one, you'll see that it is a higher quality. Okay. The image will always be grayscale, so brighter colors. So whiter colors would be have heavier elements within them, and darker ones would have lighter ones. So this one I think is magnetite, and this is mica. This is this is K feldspar, plagioclase, quartz. Like I have mentioned, don't touch the rotate, the tilt, or the Z positioning of the stage. Okay. So when working with the SEM, everything will be set up. So you'll basically come in and you will push this button over here, and that will switch the beam on, and you will start with your analysis. Everything else will be done for you. Three things that you have to do is you have to focus your image. So there's more than one way to do that. There's an auto focus button over here. There's an auto contrast and brightness. Okay, so if the contrast and brightness isn't correct, then you aren't able to see the boundaries between the different minerals. Okay, so I've already clicked it for this one, and you'll zoom. Okay, so if I go to scan 2, you'll see that I zoom in and I'm zooming out. Okay, so that's the scroller on the mouse. Other ways that you can do that is there is a controller over here. You'll see there's magnification, so increase, decrease. and this is your focus button. The focus has two options. So you'll see that there's a coarse button, and when the light is on, now it's off, when it's on, then it's basically like using the bigger knob of a microscope, and when it's off, it's like the smaller one. So when it's on, you click one at a time. When it's off, you can scroll a little bit more. Okay, movement can also be done in a number of ways. If you double click, then that position moves to the center of the screen. Otherwise, you can click on your thin section over here and you'll see that it moves. Okay, so I would say zoom past this, because this is basically the rim of the cone where the beam comes out. So if you zoom past that, you have to move to scan 3 to do anything, to make sure your focus is correct. Okay, closer you zoom in, the more detail you'll be able to see, and you'll know that your focus is great or not. Okay, so that's a pretty good focus. And this is how you take photos. So if you click on this button, there's an orange line that starts on the left at the top and it runs all the way down to the bottom. Okay, takes quite a bit of time, so a couple of minutes, and then it will give you an option here to save. Okay, and you can save it in a folder on the desktop. So create a folder for yourself on the desktop and you can save your images. Okay, so this is an image that's been taken a couple of minutes later. There you will see the save button. So you can save it on the desktop, create a folder for yourself, and you can save it. Okay, and you will see that all this information is burned into your image, which is what you need. Scale bar, magnification. So say that we would like to see what the difference is between this mineral and this one. Okay, so we bring it to the middle. I'll zoom in slightly. Okay, always be on scan 3 when you're going to do analysis. Okay, remember, smaller objects need to be zoomed in further, so that your beam does not analyze the material around it. Okay. So this is the right-hand screen. As you can see, this is the screen, as I've mentioned, that does analysis. Okay. So the analysis that you will do the most is point and shoot. So if I click on that, then I acquire an image in the top here. You'll see that it's an image where it looks like it's grading from dark to light, and if you click on that, then it gives you your image. Okay, so I said let's look at the difference in the composition between this and this. Okay, if these are all grayed out, just click above your image. Okay, then you put in points, and you click play. Then the analysis will run. Okay, so the analysis is done. In order for you to get to all your points, you click on the yellow arrow over here, that one, and you start with point 1 and you quantify it. Okay, it looks like a little scale with a percentage above it. And under quant results over here, you'll see your results under compound weight percent. Always remember that with silicates, for example, you have to have, under analysis setup, it has to be a compound for all elements. Okay, then you just re-quantify and it looks like this. Okay, so magnesium, aluminium, silica, potassium, titanium, and iron. Okay, so there's your results. We click on 2, quantify it. Okay, a lot more iron. And 3, quantify, and 4, quantify. Okay, is the amount of magnesium and iron. Okay, but I suspect that they are both micas. Okay, obviously you'll have to go and do an calculations like you did in third year, where you actually determine the chemical formula of a mineral. So you'll have to do that. Okay, and exporting your data, you click on, there's a Word document at the top here, you click on that, and it basically pastes the picture, the graphs, and don't forget that you're going to use a table that says compound percentage. Okay, so this one, all the other ones you will ignore. Okay, so we use this table right here as your results. Okay. Okay, there are other options for analysis. So there's spectral imaging, for example. If errors pop up, just click OK. You acquire an image gain and you click play. Okay, so this is the result of an elemental map. So it will show you where there is more of an element and where there is less, for example here in the silica. And this can also be exported into the Word document by clicking the Word document icon. Okay, so it gives you the image and it gives you the elemental images as well. You can label your analysis by changing the name of your analysis at the base over here. So it says base name, so you can type in your sample name and that will then be connected to your image, and it is also connected to each of your analysis. So in this case I have zoomed in because these minerals are quite small, so that when we take it to the right hand computer, that when we put a point down, remember that you must take the yellow arrow off to put down points, and click play. Then I am analyzing only that mineral and not the material around it. So that is dependent on the spot size. So the smaller objects you have to zoom in more so that your beam only penetrates that mineral. Okay. Okay, so in order to send your data to yourself, the only way that you can do it is literally via email. You are not allowed to use USB, so flash drives, or hard drives, or external hard drives, or anything like that. And you are welcome to use CDs, but it is easier if you just use your email. So the left-hand computer is not connected to the internet, but the right-hand computer is. And on the right hand side you'll see there is a file called tense share right over here. So this one is basically connected to the right hand computer. Okay, so if you copy and paste your folder on the left hand side into this folder, it will appear on the right hand computer. You'll see there is also in the bottom right corner over here, there is the same folder and everything will be there. And then you can use Google Chrome, log into your email and send it to yourself. Okay. So please note that I am able to help you with the machine, putting your samples in, if there are issues with taking your analysis, but I am not able to assist you with what your results should look like. This is something that you should research before the time. What is the point of you doing the study, and how many analysis you need to take, and what does your report need to look like, that I cannot assist with. That you will need to ask your supervisor or your lecturer at that for that subject. That unfortunately I can't assist with.